talking about chapter 12. In chapter 12, we're going to talk about modeling some functions, specifically polynomial functions. And that's kind of where we're going to start here in section 12.1. Is just a discussion of polynomial functions. So this is something that we would have talked about also last year in your Algebra 2 class. But it's always good to kind of review this stuff. So a polynomial function is something of the form f of x equals a sub n, x to the n plus a sub n minus 1, x to the n minus 1, yada, 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 all the way down to a sub 1, x to the first plus a sub 0. The a's there are called the coefficients. Those a's have to be real numbers. And the first coefficient has to be non-zero. The exponents, the n, n minus 1, etc., have to be non-negative integers. By integers, we mean whole number, no fraction, no decimal. So non-negative means 0 is okay, but like -1 would not be. Everybody's cool? And then obviously x is the variable. Okay? We say that a sub n is the leading coefficient. So that's the special coefficient. And we say that n is the degree of the polynomial. So let's take a look at some examples, and we'll just decide whether something's a polynomial or not. And then if it is, we'll talk about its degree and leading coefficient. Sound good? So we're just going to burn through some examples about identifying whether something's a polynomial or not. So our first one, 4x to the 6th minus 5x squared plus 2x minus 1. What do we think here? Yes should be the answer there. I see some people shaking their heads yes. So the two things you need to check is if you look at the coefficients, are all of those real numbered? Yes. And then we have to check the exponents. All the exponents there are non-negative whole numbers, and the only operations that are going on is multiplication in between the variable and the coefficient, and then addition or subtraction between the terms. And I guess that's worth stating, like if we go back up here, each one of these guys are called a term of the polynomial. Probably worth stating that. Those are all that, each one of those would be a term. So since this is a polynomial, what's the degree for this polynomial? What do you guys think? It's 6. Just the biggest exponent on the variables. Cool there. Okay. And what's the leading coefficient? It's 4. It's the coefficient on the highest degree term. Okay. Let's continue. We're going to do a bunch of these. So our next one here, g of x equals square root 3 times x minus 6. What do we think here? Polynomial. You say yes. You say no. Okay? So what are the things that we need to check? Or actually, let's start here. Jack, why do you say no? Because of the square root there. Right? Now, kind of depends. The square root in there doesn't necessarily make it not a polynomial. It depends on what's underneath the square root. So in this case, what's underneath the square root? Just the number 3. Well, is the square root bar going over the x? Just the 3, right? So is square root 3 a real number? Yeah, so that's fine. Negative 6, that's a real number. The exponent on my variable is non-negative. The only operations going on with the variable is multiplication to a coefficient and then like addition or subtraction of the term. So this looks good. Yeah, we would say this is a polynomial. What's the degree for this polynomial? What's that? 1 is correct. So remember, even though there's no exponent written there, we know on an x, there's really an exponent of 1. And then the leading coefficient would be not 3, not 1. Square root 3. Yeah. So far, so good? About the square root of 9x to the 4th plus 16x squared. Is this a polynomial? No. Okay, see people shaking their head. Why do you say no? Specifically, what's underneath the radical? Of the variable, yeah. Right? We have variables underneath the square root. That is correct. So this is not a polynomial. How many of you looked at that and said, oh, well, I could just take the square root of each term, and now it'd be a polynomial, right? Who says this? Shane says it seems like I should be able to do that. You cannot do that. So what's wrong with what you've done there? Certainly the square root of 9x to the 4th is 3x squared. That's correct. The square root of 16x to the 2nd is 4x. That's correct. But why can't I do this? This is like an aside here. Well, this is why. Because the square root operation doesn't distribute. So because we have that addition and subtraction symbol here, doesn't allow me to break the square root like that. Again, that's like a little aside. It's not necessarily relevant here, but like it's kind of on topic, and it's a mistake I see students commonly make. And we're nearby, and it's something I could see somebody doing and saying, oh, well, yeah, I can make that a polynomial. Look. Does that make sense, though, as to why we can't do that? And if you tried it numerically, it should be really obvious, right? Like if I take, the square root of, the square root of 1 plus 4, well, that's the square root of 5, right, which is 2 point something or another. But if I broke this, I would get 3, and the square root of 5 is definitely not the same thing as 3, right? Just to kind of demonstrate that if you're like, ooh, can I do that or not? You can always try like a little simple numeric example to check to see if it's okay to do what you're trying to do. Does that feel okay? Again, just still on that same tangent there, but it felt like a good tangent, right? How many of us had kind of forgotten that you can't break a square root in addition and subtraction? Probably a lot of us had forgotten that at this point. You know, it's been a minute since we've been back there. But it turns out really the only operation you can distribute is that multiplication division kind of thing. Nothing else that we've seen does that. So if you're ever questioning, ooh, can I distribute this thing? Chances are the answer is no. All right, let's do another. So we have 5x squared plus 6x plus 2x to the negative 1 plus 5. Is this a polynomial? Lots of people shaking their heads already. Why not? Yeah, this guy right here is enough to say no. Okay. Well, let's just do this. What if instead I write it this way? Is that a polynomial? So 5x squared plus 6x plus 2 divided by x plus 5. Yeah, so no is the correct answer, and the reason is that you're dividing by a variable. Can't divide by a variable. What if we had this one? 5x squared plus 6x plus x over 2 plus 5. Is that a polynomial? This is. What the heck is the difference, right, Mr. Kulik? Well, if you think about it for a moment, you can rewrite this as 1/2 times x. So really all you have is real number coefficients multiplied to a variable, and then the terms are added or subtracted. It's no problem. So the takeaway here is the x in the denominator. If you have a variable in the denominator of a fraction, that's bad. Can't be a polynomial function there. But if you just have a number in the denominator, a real number, that's fine. You guys feeling okay here as to what's a polynomial and not? I think we covered everything that would be kind of goofy. Okay. So the next thing we'll talk about is naming polynomials. We really have two ways to kind of name them. One way is by their degree. So we have a couple of the degree is equal to 0. We call that a constant function. And you might say, what does that look like? Well, like f of x is equal to 7. Wait a minute, Mr. Kulik, why is the degree there 7, right? The exponent on 7 would be 1. Everybody agree with that? But why are we saying it's degree 0? Well, the degree is on the variable part. Since there is no variable part, we can think about that as really just 7 times 1, right? And remember that 0 to, or anything to 0 power is 1. So really I can tack an x to the 0 on at the end of that. That's why it's degree 0. Does that feel okay to you guys? And really when I said anything to the 0 power is 1, I mean anything other than 0 to the 0 power is 1. 0 to the 0 power is undefined. Just as an aside. But I don't want to say things that are wrong, right? Like, that's not helpful. If the degree is 1, that's a linear function. So an example there might be y equals x plus 5 or something. If the degree is 2, that's called a quadratic function. So that could be something like x squared plus 3x plus 2. The degree is 3, we call that a cubic function. So maybe we have 5x cubed minus 2x plus 1. Just as an example, I'm just making stuff up. And the last one that we're going to give a name for is degree 4, which is quartic. So an example there might be 2x to the 4th minus 6x squared minus 2. So degree 0 is a constant function, degree 1 is linear, degree 2 quadratic, degree 3 cubic, degree 4 quartic. Like 4 quarters, degree 4 quartic. So that's just like some simple names, right? No big deal here. The other way we name things is by the number of terms. So if we have one term, we call that thing a monomial. So like 6x squared is a monomial. Two terms, we call that a binomial. So for example, x plus 7 has 2 terms. That's a binomial. 3 terms is a trinomial. So 3x cubed minus 2x plus 7 could be an example of a trinomial. That's as far as we'll go naming what terms. So just run through a couple of quick examples here. We're going to name the polynomial functions. To name these, first thing we'd want to do is to determine the degree. and then the number of terms. So for this one, f of x equals 2x squared minus 3x to the fourth plus 2x. What's the degree? Four, right? It's the biggest exponent, not necessarily the first one. And the number of terms is 3. Okay. Since it's degree 4, it would be quartic. And since there's 3 terms, it would be a trinomial. So we'd say that's a quartic trinomial. Right, pretty easy. Let's do one more example just to be sure. Sound good to you guys? Okay. So the degree here is 2. Great. And the number of terms is also 2. So because it's degree 2, we'd say it's quadratic. And because there's 2 terms, we'd say it's a binomial. Pretty easy, right? Not a big deal. Maybe you have to get used to remembering what name goes with what, but it's pretty simple. No calculations necessary at any point in this whole section, right? We're just talking about names and using a definition to see if, like, is this thing that I've written down meet the qualifications for this definition, right? We're going to stop here. So at this point, you'd be able to do 1 through 4 from chapter 12. We're stopping here.